Morning everybody. Today we're going to start looking at the quotient rule. The quotient rule is quite similar to the product rule. However, you hopefully, by just seeing the word quotient, and from thinking about what we did yesterday in terms of multiplying, you'll think, okay, well this has also got something to do with division. And so let's just crack straight on. So for some equation which has got a function in x in the numerator and a function of x in the denominator, extend that vinculus, then the quotient rule says that dy dx is equal to v du dx minus u dv dx all over v squared. Okay, so just a couple of points on this before we go any further. You guys don't get this in your formula book, so you need to remember this. And you'll probably remember from yesterday that the product rule is this. Move the screen to see what I highlight. U dv dx plus v du dx. Now I always used to remember this one fine because you differentiate one, leave the other one alone, and add it to the other way around. However, when I was your age, I used to forget this all the time. So what I actually ended up doing was I started writing the product rule like this all the time. I used to write it as v du dx plus u dv dx. Now I've shown you how to do it this way yesterday because that's how you'll see it everywhere. Every now and again you see it written as u v dash. The v dash represents the dv dx plus v u dash. That's a perfectly acceptable way to write it. But I started writing it like this instead because I knew if I always wrote the product rule out, sorry, not the product rule, yeah, the product rule out like this, then when I came to the quotient rule, all I need to do is change the plus to a negative and divide through by v squared. So if this is one of these things which you might think that you might end up forgetting, then here's a little trick for it. Always write your product rule out this way. You can't not write the quotient rule out this way, and then everything's actually in the right place, and you just need to remember to change a plus to a minus and divide through by v squared. You can quite easily prove this from the product rule. Feel free to have a go at that one if you so wish. It's essentially we've got this function times this function to the power of minus 1. And so yeah, that's quite a nice thing to prove if you want to. So let's just try an example straight away, and I'll let you crack on with some of these because there's fairly little to talk about with this unless you're going to try and prove them. So let's have y is equal to x squared over 1 plus 2x cubed. Just before I go any further, you'll notice that with this differentiation, all we're doing at the moment is just really simple type functions. We're just doing polynomials and divisions or products of polynomials. We haven't got any sines or cosines or things like that in. And you'll also notice that this, you won't notice this is, oh no, you have the year 2 books, don't you? Of course you do. You also notice that this chapter isn't really in your book per se. Now there is a differentiation chapter, but it sort of brings all this stuff in with sine and cos and exponentials all at the same time. I just think it's far too much. So at the moment what we're doing is we're just looking at these 3 main rules, and we'll come back to that big chapter in your textbook a bit later on. So if you have been looking at that thinking, gosh, when am I going to get to those questions, don't worry, we're not going to deal with that right now. Okay, so this is, if I want to differentiate this, it's quite blatantly a division, so I'm going to use the quotient rule, and I'm going to set up the same as I did yesterday for my product rule. I'm going to specify what I think u is and what v is, and then I'm going to differentiate both of them. So du dx dx is 2x, and dv dx is going to be 6x squared. So now I can just plug it straight into my formula. I would advise you to write the formula out every time, and the reason for that is it will just stick in your memory better if you write it out over and over again. And if you just look at it in your book, or you find yourself flicking back to your notes all the time to remember what the formula is, that is definitely a sign that you should be writing this out all the time. Okay, so let's substitute in. I've got v is 1 plus 2x cubed, du dx is 2x, take away x squared, lots of 6x squared. I don't really need the bracket there, I could have put a times, in fact I'm going to put a times, I'm not sure why I put that bracket there. And there we go. And that's all going to be divided by v squared. So v is this thing, oops, that thing, 1 plus 2x cubed, and it's all squared. Okay, from here, tidy up the numerator, don't expand the denominator out. So if I tidy up the numerator, I'm going to get 2x plus 4x to the 4 minus 6x to the 4. And from here, what we would like to have a go at is just, well actually we can just tidy up the numerator a bit more, can't we? Let's just do that. So we just tidy that numerator up slightly more to get 2x minus 2x to the 4 over 1 plus 2x cubed squared. And hopefully from here you can start to think, okay, well, is there anything here which I can possibly cancel at the bottom? In this particular case, there isn't going to be anything, but the reason why you don't expand this out, the denominator that is because sometimes you'll get something that cancels the numerator here, and it's easier to see when it's in brackets. In this case there isn't, so all we're going to do is just factorise the numerator as much as we can. So we can take a 2x out, and that leaves us with 1 minus x cubed, and we'll leave the denominator as it is, 1 plus 2x cubed squared. Okay, so some questions for you guys to go away and do. So using the sheets which I gave you yesterday, you can find them on ClassChart still, or they're still on the VLE as well. So from the level 1 sheet, can you do questions 3, 4, 8 and 10? And from the level 2 sheet, can you have a go at question 4 and 9, no, why not 10? Okay, that should suffice for today. Hope you have a nice day, and I'll speak to you again tomorrow about some other bits and bobs. Thank you, bye bye.